let's talk about Uber and their internal on-call copilot called Genie, where they do a bunch of interesting stuff around retrieval augmented generation. Actually, they called it Enhanced Agentic RAG. They wrote a recent article on that, so let's look what exactly is happening there and what we can learn from their approach to RAG systems. So Genie is this on-call chatbot which is designed to provide real-time support to subject matter experts, and not only it will answer the question but also will give citations to the Uber's internal documentation where that information is taken from. And there is plenty of that information. So apparently it is designed to integrate nearly all internal knowledge sources, which can be in different shapes and forms. For example, like engineering wiki, there can be PDFs, Google Docs, custom documents. And all that information is supposed to be part of the retrieval augmented generation pipeline, which will take those documents, it will read those documents, process, then vectorize that knowledge, then also be responsible for retrieving the knowledge which is necessary to answer the question, and then also answer the question using an LLM. However, this is not easy. So they developed the system and apparently they tested it on a part of the documents and also some particular use cases, and they used curated golden set of 100 plus queries and realized that the results are quite unsatisfactory. So the results revealed significant gaps in accuracy for the answers, and they were incomplete, inaccurate, and failed to retrieve relevant information in correct detail. So they were quite unhappy about it. And they made a change to the system. In particular, they changed quite a lot how retrieval augmented generation pipeline works and what exactly it uses as a basis, how it transforms those PDFs and so on. And they managed to increase the acceptable answers by a relative 27% and also reduce incorrect advice by relative 60%, which is quite a lot. So what did they do? First thing first, they fixed how they were chunking big documents, especially those PDF documents with a number of tables, bullet points. They mentioned here policy documents containing complex tables spanning more than 5 pages, including nested table cells. So those documents were split into multiple chunks incorrectly, losing the context. And then when you retrieve the chunk of information, it was not giving the whole necessary information for the LLM to answer the question. So they were unable to find a universal solution that worked across all of their policy documents. And apparently they did multiple iterations. They transitioned from PDFs to Google Docs using HTML formatting. Then they were using HTML to text to parse Google documents as a markdown formatted text. And all in all, they say that they built a custom Google document loader using the Google Python API. So they were extracting that information recursively and doing it on their own instead of using pre-designed tools for that. To make things even more interesting, they actually used LLM for the enrichment process. So they asked LLM to convert extracted table contents into markdown formatted tables. And in addition to that, they added some metadata, some identifiers, so that they can distinguish this table containing text chunks to ensure that they remain intact during chunking, so that they are kind of going all together. And they added a summary and few keywords from the table to the corresponding chunk to improve the relevance of the semantic search later. Over here they show more or less how a table looked like after that processing step. So start of the table, end of the table, some information, some columns. I'm not sure right now if it's already like a single chunk, because it looks like a single chunk, probably it is. Then, in addition to that, they actually added some metadata for chunks and metadata for the whole document. Here they're talking about document summaries, then a set of FAQs and relevant keywords into the metadata. So the FAQs and the keywords were added per chunk. So it was done after the chunking step. Kind of information, for example, here it would be FAQs and the relevant keywords. But the summary would be actually same for all the chunks from the same document. And all of that helped later during the retrieval process to get more relevant and clear chunks. They also mentioned here something interesting because they're using offline feature store. So all those artifacts like document lists, titles, summaries, and FAQs from the enrichment process were stored in an offline feature store for later usage and answer generation. Then, unsurprisingly, they were using a couple of agents. And the issue which Uber has, they have a lot of those policies, a lot of those documents. And those document chunks often can have only just subtle distinctions. So it would be quite difficult also to find the correct documents because they have differences in variations in data retention policies, data classification, sharing protocols. So those small things make a huge difference when you answer a critical question. And taking wrong chunks will lead to retrieving irrelevant context and giving the wrong answer to that question. So they approach this problem from 2 points. First of all, when the request from the user is taken, it's actually being refined by an agent called Query Optimizer. So Query Optimizer will take the query from a user. It will either break it down into multiple queries or will more or less tries to refine the query for the better response. And then from the second angle, they do have source identifier, which will process this optimized query and then will narrow down the subset of policy documents, which most likely will contain the relevant answers. And while doing so, these two agents will use those title summaries, FAQs, which were stored previously during the chunking process, so that what they call document list artifact. And they will use that information to correctly identify the sources and refine the query. In addition to that, they introduced also a BM25 based retriever alongside the traditional vector search. So vector search is where we are using embeddings and those vectors to find similarities, but they also use the keyword search. This is BM25 based retriever, what it is, based on my knowledge. They took the union of the results, so the vector search plus the BM25 retriever. So they took all of that together, then they deduplicated the whatever was in two positions, structured the context according to the positional order of chunks. I'm not sure what that means. And finally, they got all of the information and gave to the LLM to answer the question using this context. To evaluate how Genie is doing and how well it replies to the questions, they used an automated process, LLM as a judge. So they used LLM to judge the responses from LLM. This is actually a combination of work between the LLM and also subject matter experts. So they mentioned that actually for subject matter experts, it takes quite a lot of time also to do the evaluation. So they do it one time manual subject matter expert review, and then they use LLM evaluation. And LLM as a judge gives a score response based on 1 to 5 scale, 5 being the highest quality. And it helps to do this faster evaluation and incorporate the feedback into the future experiments. From the technology point of view, they use LangChain, and they mentioned that they might consider using LangGraph for future expansions into more complex agentic frameworks. In the end, they admit that this is probably an early step, and in the future they would need a more complex architecture, especially if they want to take care of multimodal content such as images, and that probably they will use an iterative chain of RAG approach to enhance performance. It really resonates with my experience, and I never could understand people who do just random chunking, because then you get random chunks in the similarity search which don't contain the full context to give a good answer by a large language model. So it's cool to see this particular flow, and definitely something to keep an eye on.